Peggy invests $10,000 when her grandchild is born for the child's college education. She records the value of the investment in a table according to the annual statement she receives from the investment firm. Use successive ratios to generate a function model. Then use the function model to predict the worth of Peggy's investment after 18 years when her grandchild is ready to enroll in college. Determine the reasonableness of the prediction. Okay, so let's just first point out let's first point out the independent and dependent variables. So the time would be the independent variable, since that is just going to march on no matter what. We can call that t. And then the worth of the investment would be our dependent, and we can just call that w for worth of t. And so note here that our delta t would just be 1, since it's going up by 1 year every time. And then for our successive ratios, then we could go ahead and divide 10,304 and 1600ths divided by 10,000. And so dividing those, we get 1.030416. And then dividing the next, then we get almost the same thing, but it's going to be at the end 158. But if we round it to that same 6th decimal spot, then we will actually get these same things. And again, for the next two, they each have a slight variation, but rounding it, then they all have the same exact ratio. And so remember that this is a percentage would be a little bit more than 103%. And that just means that each year you're going to keep what you have, but then it's growing by 3%. And so that's going to be our interest rate. So we can just say, and note here, our interest rate will be 3%. And so then to write a function, then we know it would be WT equals, and then the starting value, so when t is 0, then we have a $10,000 investment, and then times our rate that we found, and then raised to the t, since our delta t is 1, and that's our time. So let's go ahead and find then for 18 years how much would be predicted to be in the account. So we'll find W of 18. And so plugging that in there, then in the calculator we get 17,148, and then rounding it to the nearest hundredth, since this is in dollars and cents, then we get 52 hundredths. And so that's the predicted amount for when her grandchild is 18. And then to see if that's reasonable, we can use the rule of 72, and that just means that the investment will double. So instead of 10,000, it will become 20,000 when we take 72 divided by the interest rate as a percent. So our interest rate as a percent is about 3. So 72 divided by 3 gives us 24, and then that would be the number of years that it's predicted to make it to $20,000. And so 17,000 would be reasonable, because we definitely know that at 18 years it's going to be less than 20,000, but it'll be much more than $11,273, because that's only when t equals 4, so only at 4 years. So it's going to be much closer to 20,000. And so this is a reasonable prediction. So let's go ahead and summarize our answer. Let t represent the time in years since Peggy's grandchild was born, and WT represent the worth of Peggy's investment. Using successive ratios, WT equals 10,000 times 1.030416 to the t, which means that the interest rate is about 3%. The modeling function predicts that Peggy's investment will be worth $17,148.52 when the child is 18 years old. Using the rule of 72, which states that an investment doubles in value every 72 divided by the interest rate as a percent years, the investment would be worth $20,000. Approximately 72 divided by 3 equals 24 years after the initial principal investment. The investment having a value between $11,273.28 and $20,000, but closer to $20,000 after 18 years, is a reasonable prediction.